Let's just do the little chart here. Some of you probably have seen some of this. 802.11b. Anybody remember that? It uses 2.4 gigahertz, and you would connect up at 11 megabits per second, and you get about 5.5 megabits of throughput. That was the very first wireless that you probably used at your house. And that's what we gave the businesses. And you know what? They said it's really cool until we started getting more people on it. And they said, God, it sucks because it's slow. So what do? We had to get better. So we got 802.11a. People said, let's go to A. It's 5 gigahertz. It can give you up to 54 megabits of connectivity and about 25 megabits of throughput. People said, I like that. How do I get from here to here? How did you get from here to here? Bought everything new. Bought new access points and bought new clients. So how many customers moved from here to here? Yeah, probably 10%, 15% maybe at the top. Customers said, no, I'm not going to do that. Yeah, didn't want to do that. So we came up with 802.11g, which goes back to 2.4 gigahertz, gives you the 54 megabits per second and about 25 megabits of throughput, and is backwards compatible with 802.11b. That's where customers went, because they had B clients and they had G clients that would work together. They didn't have to upgrade their radios. Yeah. And then people said, well, 54 megabits is great connectivity and 25, but I want more. So they came up with this 802.11n. Now N, God, it took 3 years to get this ratified. So it was proposed for 3 years. Promises, promises. Promises, promises. 802.11n, they said, we're not going, it's the 2.4 and 5 gigahertz, and we're going to say we're going to give you 100 megabits of throughput, no matter how many signals you need to connect up, how many devices. The problem is it took a long time to get this, and you're going to have different flavors of this. What's the difference between an iPad and an iPhone 4S? This is an iPhone 4S. It's 802.11n. When you look at it, it says, put this down, 802.11n, but it says, after it says BGN. What frequency radio is in this? Only a 2.4. An iPad, 802.11n, and it is ABGN. It's got two radios in it. It can either be on the 5 gigahertz or the 2.4. Yeah. That's the difference between some of the little nuances now. So let's just think about it. Everybody's got iPads and everybody's got iPhones. Do we want them all to go to 2.4? We might want to take the iPads and put them on 5 and the iPhones and put them on 2.4 so we actually have better service for everybody. Wouldn't that be right? Guess what? Cisco's got something called Client Link that does that. That'll actually look at the device and say, where can you go? We can sour 2.4 to drive you to 5 gigahertz and take all these people that can get over on that 5 gigahertz. First thing you need to do when you talk to customers about wireless is tell them, get off of 2.4. It's going away. It's going away. And it will. 5 years from now, you'll have no 2.4 stuff out there. You won't. Because when they do the next series of this, the next wave that's coming is 802.11ac. And what's your customers going to think? Just think about this when they say, hey, listen, it's going to use the 5 gigahertz frequency range. That's a Z, by the way. And it's going to give you 1.3 gigabit in wireless. What do you think they're going to say about that? I like that. Yeah. And when you tell them that, and it's going to 4 gigabit. Eventually going to 4 gigabit. That's where wireless is going. Guess what's being left behind? 2.4. They call it the junk band.
Doesn't the 2.4 cover a wider area?
Yes, it actually does. And again, if you think about a frequency, a 2.4 gigahertz frequency, it has less turns per kilometer or per meter or whatever, right? So you actually keep your signal strength longer. Where 5.8 is going up and down, and you lose energy when you do that. Yeah, and everything. But guess what? We'll just increase the power, put more access points out there, because we can get so much more bandwidth off of it. There's just so many more channels there that we have to do. What we're doing is we're taking channels and bonding them together. So when we want to get 1.3 gigahertz, you only get 9 channels of that, because we're bonding multiple channels together to give you the best bandwidth. That's what you're doing.
So how far away is AC?
Well, it's supposed to be December, right? December is, I mean, it's proposed. There's actually selling pre-standard access points for it. There's not any clients out there that I'm aware of. But it's actually supposed to be ratified this month by the IEEE. Well, we have a product line that will come out and do that, right? But to be honest with you, without the clients, who cares, right? Our products are modular enough to where you can actually replace the radios and upgrade them in the field. That's the one thing that we have designed our access points for. But again, it's going to take a long time for this to weed out. But it's coming, and your customers need to know about that now. First thing you need to tell your customers now is get off 2.4. Anything 2.4, please relieve yourself of those, because it's not going to help you. I've got a customer who has a manufacturing plant, and it's going to cost him $30,000 to get out of 2.4. I've already told him, you better start putting money in this bank somewhere, because you're going to want to do that. You're going to want to do that.
Maybe in all this, right, I mean, AC or our products, how does coexistence come into the picture? I mean, with Bluetooth or NFC or all that?
Well, if you think about it, if you do Bluetooth, Bluetooth's operating on 2.4. So is it going to bother you? No. Does AM radio bother FM radio? No. That's what you're doing.
Talk about Bluetooth over Wi-Fi as well, right? As part of the Bluetooth standards.
Bluetooth is actually 2.4. So that's where you get your interference from. You're going to a whole new frequency range. It's like going from AM to FM. Yeah.
What will happen to customers who already have the new access points, which is 802.11n?
Uh-huh.
Now with the AC coming.
Yeah, well, you know what? It's going to be a while. Listen, it's not like you're just doing your house. You know, a geek like me, as soon as the AC's out and I can get clients, you know who I'm going to do it, because I'm a geek. And my wife's going to shop at Talbot's, and I'm going to buy electronica gear, right? That's the way our house runs. But as a business, it's going to take you a while to do that. It's going to take a while for those. Think about it. Even people still lease PCs. Do you think they're going to put, boy, this is nice. God, I like this. You know, I'm looking at mine and I'm feeling this is nice. But this isn't going to be AC. It's not going to be able to do it. But you're going to keep this for quite a while. So it's going to be 2 or 3 years before AC is going to be across all your devices you're getting and all this, that, and the other. But customers need to start planning on doing it now. Because the first place you're going to see these are all the devices that need the bandwidth, the video devices, the things like that. That's the things that people are going to start doing. Those carts that they want to have. I've got a customer who's doing telepresence over wireless now, and it works really, really well. But they might want to start doing that across multiple carts, right, in different places. And they're going to say, hey, I want those carts to be on AC so I can share more bandwidth versus the 2 or 3 carts that I can put on the floor now to be able to do it. Does it make sense? Wireless is such a cool topic to be able to talk to a customer about. And again, Cisco's, at one point Cisco almost had 60% of the market share. Today they're about 50%. Aruba has chewed up a lot. Maru Networks has came out and done it. A lot of these lower cost, AirHive with some crazy technologies and all this, man, there's been some crazy technologies come out with this stuff. But Cisco's still a dominant player with 50% of the market. And I think with what Cisco's done, and we'll talk about it tomorrow when we reconvene and everything, we'll talk about the features in wireless that are driving, that will drive you to what you can talk about with your customer to win the wireless side of it. And we do have features that are doing that. Remember that MSI I was talking to you guys about the video and all that? Guess what? We're going to put that to where the access points can actually read that. And the access points. So they're going to be able to have a lot of people, they're going to be able to pick out video in there, video streams, and be able to do QoS on, even on those. Application-specific QoS on wireless devices and our access points. That's what's coming. Now today we certainly have some other things that are here today. For the next 2 years, yes. 2 years. Yes. But I would encourage all of my customers today to seriously start investing in only 5 gigahertz technology. I've told my customers that. And this is why.
But even if they invest in 5 gigahertz technology, their existing access points.
Absolutely. But they need to start planning on that, because eventually that 2.4, again, 2.4 is the junk band. You're already having saturation problems with it. And I would rather have them on 5 gigahertz today and be able to deal with that than I would the other. Because again, I have 20 channels here I can choose from. I only have 3 there at my best. Do you think there's going to be more devices or less next week in your customer? More. There's going to be a few more. A few more every week. And all of them are definitely going to be 2.4. If they're 2.4, they're definitely going to cause a lot more headache. All right. So let's wrap it up now. And we'll continue with this tomorrow. We'll do a quick review tomorrow morning and then continue on with this. We're right on time for a on-time departure on Friday, as they say in the airline industry. So, yes, sir.
Question about the standard. I have read, I don't know where, that for example, if you have the 80, if you have the N version, the access point, the throughput at that, if there's a device, N is comparable with the rest of the release.
Right.
If a device that is, for example, B attaches to the
Slows them down, absolutely. Absolutely.
lows, all the devices.
It slows them down. Now, it doesn't slow everybody down to the slowest B speed, but it's kind of like this. Let me give you this. Let's say that B is like this. Your turn, your turn, your turn, your turn. That's B. Now, your turn. There's a B device here. All of a sudden, I upgrade these guys to N. It's your turn, 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 your turn. So it does slow them down. It does affect everybody else, because not everybody's getting the optimal performance, but it doesn't drag everybody down to your speed. It just, no, it doesn't. It doesn't. It doesn't. So let's just talk about N and some of the capabilities. I kind of started it yesterday, and it's kind of late in the day for all of us. But 802.11n is backwards compatible with your older clients, the A and the G clients and all that. But and we all don't have. There's a lot of customers who still have G clients in their PCs and their equipment that they're using and all this, that, and the other. Not everybody's N capable. But from an access point, you think about it. If you look at the access point up on the ceiling there, the access point sends out its radio signals everywhere. Everywhere. Like that. And let's say we're in a room, and here's my PC with a wireless NIC card in it here, and it's trying to connect up. We used to have problems with this when we turned the power up real high. Because in a room like this, if we're in a room, and this is where I'm setting, I'm going to see a radio signal. The best radio signal I see is probably direct into my client. And that's the best signal I see. But you know, these radio waves are going everywhere and bouncing around. You don't see them, but they do. This signal is going this way and hitting the floor and bouncing, and I'm seeing that signal bounce off here. I'm seeing it bounce off the ceiling. I'm seeing it bounce off everything, everywhere. Each one, and what we used to have to do, because the clients couldn't accept that, the old B and A clients couldn't accept these signals. They would go, oh my God, that's good, this is good, this is good, that. It was bad. So what we did is we turned the power down and decreased our circle of coverage until these signals were so weak that it always chose this direct one as the signal of choice. We had to do that when we do our site survey, or when our partners do our site surveys for us. Yeah. And that was the whole, and by the way, site surveys are probably one of the most underused ways of finding out about your customer. Let me give you an example. I used to go to all the site surveys, at least the initial part of them, with my customers, and here's why. Site surveys happen in 2 phases. The first phase is the customer says, I'm thinking about doing wireless and everything, and I want to go in there, and so we would go in, our partner would go in, and we sit across the table, and we have their floor plans if we can have them and all this. And they tell us, well, what's your project that you're doing? Why are you doing this wireless? You just have that little discussion. What are you finding out? Why they're doing that? What does that give you from an account manager perspective? Why are we doing this? You find out inertia, why there's movement. Somebody is spending money for some reason. Some business person probably has said, we need wireless because of this. And if you can find the root of that, you can find somebody in the account, business person, that's got a need. They've got a need. And that's somebody that you might want to talk to. That's the one thing. And then you say, okay, so what kind of clients are you going to use and what kind of coverage are you going to expect and all that. So you sit there and have that discussion. And you also get to talk about, well, okay, so you've got these clients and this coverage. Where do you want wireless? Where do you not want wireless and all this? You say, okay, what applications do you plan on using across this? Well, that's important. Isn't it nice to know what customers' applications are using? It might be important to you to know. You might get a list, pretty good list of their applications. And then you ask the follow-up question, what applications don't you want on this? Or is there something there that you really don't want these people to access? That's a legitimate question because we can filter out stuff. At a router port, we can filter out applications. What else is it giving us? A complete list of the applications the customer sees as valuable to their business. And it may be something you can use in your account planning at some point to find out, well, if we can do something special on something somewhere about that. Wow, wouldn't that be cool to do? So you're actually getting a lot of information in the back end of this. That's what I would do. I'd sit there with them and I'd ask questions and all of this. Now the second part of that is the more difficult part, the one I don't want to have involvement with anymore, is when you actually start going out and, with access points and with all this and hooking these things up and taping different things on walls and climbing ladders. And I'm not excited about climbing ladders anymore because if I fall and break, I'm probably not going to heal real quick. I'm too old for that. Early on, I kind of thought site surveys were kind of cool because I could climb ladders and do crazy things. But I got older and smarter. And I don't want to do that anymore. Because if I fall and break a hip, I may not be able to heal as quick as I want to.
One of the comments I'd make about site surveys is that one of the key things I've found in the years I've been involved in that is you also get to identify how people are being resourced. So you're able to understand, even though it's an application or priority for them, they may already have existing priorities and no time, no bandwidth, no qualified training to be able to get it done.
Yeah.
So there's ways that you can insert yourself in.
There's a lot of services in that, right? You may find that you may be able to use the information you find there to actually place services in the account, or a partner may be able to place services in the account to be able to, hey, I'm just saying, we've got to feed our partners. We've got to feed our partners. But find out opportunities where the customer may need help. That's certainly, because there are always voids in the skill set of our customer. Always voids. They just can't keep up. They just can't keep up. So the site survey is really important. So when I would do these site surveys, I'd have to turn the power down to where this signal was weak and all that. Well, guess what? With 802.11n, they changed the game. The clients, they put more intelligence on the end client, so now they could actually use these different connections that they see and combine them for all of these speeds that we want. All these speeds that we want. So what happens is this access point might have information sending this way to this customer and information. If the client is capable of reading these 3 different streams, spatial streams is what they're called, they're able to say, guess what? I want to use this stream, and this stream for all of my traffic. They could combine those. That's how we're getting all of these massive speeds that we're talking about. 450 megabits of connectivity to these devices. We're using spatial streams to do that. If the client's capable, he can actually tell this access point, I'm using this stream, and this stream, and I'm sending a little bit of data up this way, and a little bit of data up this way, and a little bit of data up this way. They're all arriving at just a little bit of different signal, and they're going to say, I'm going to use all 3 of those. 3 spatial streams. And that's how we get all of these great speeds. All these great speeds. That's cool. That's called spatial streaming, and that's how we get all this information. We combine multiple channels for this to get more bandwidth, to where you can get 150 meg of connectivity through here, here, and here.
That's only because of the N technology.
That's because you've got N technology built on this guy. On this guy. So here's the difference between 2.4 N and 5 gigahertz N. In order to get that speed, you have to combine 2 channels here. 2 non-overlapping channels. If you do that, you're going to have to use a lot more bandwidth. How many non-overlapping channels do we have in the 2.4 gigahertz range? 3. So if I use 2 of those, I can only have 1 real channel in 802.11n using 2.4 to be able to send all this bandwidth through and you have this. So this guy, if he's 2.4 only here, he's going to have the capability of getting 150 meg. That's what 1 channel will give you. But you can only have 1 of those on any 1 access point.
But you can use the rest of the channels, even if they're not overlapping, they are using different...
Well, you'd have to space them out with different power and stuff. But in general, with 2.4, you're limited because of the non-overlapping channels. But if and again, he can send a lot of information and get all this and get all these great speeds, 150 meg, that's great. But what if this guy we're using 5 gigahertz. How many non-overlapping channels do we have there? We can have a lot more groups of these channels with that. We have 20 non-overlapping channels in that now. So we can start combining those and having more bandwidth for these. Being able to put more access points and higher densities for users. That's the better choice. What if this is a 802.11g client? Now a G client can use the 150 meg connectivity, but it can't tell this guy the 3 streams that he sees. He doesn't have that capability. And there's a lot of people who still have G clients out there. Can we make this better for him? Yes. Our access points can. We have a technology called Client Link. Client Link is the capabilities. If a customer has a G client, there's still customers who are going to have these G clients. The access point can actually, when this guy starts jumping from one signal to the other here, starts feeding back, hey, I see this in 3 different ways. He can't tell him he'd like to use it, but what he will do is he'll send the signals out a little different. He'll actually see that, let's say this signal here is arriving at the PC, and let's say this is the PC. It's arriving at this, in this sequence. This signal here is arriving a little off kilter. So let's say it's like this. So it's arriving a little bit differently out of phase. And the third signal here, which would be coming here, is arriving a little out of phase as well. That actually causes interference. It's like a wave. Here's the best example of this. Have you ever been to the beach, seen a wave? So a wave comes in, and as that wave breaks and then starts pulling back out, another wave comes in. What's it do to that wave that's coming in? It kills it. It kills it, right? So it's not as big a wave. What we can do with client link technology is actually make those waves all come in at the same time, which we just change the sync of these two here to match this one, and they all arrive in the same format, like that. So you actually get better strength. If you can combine 1, 2, and 3 waves and let them hit the beach at the same time, you can surf. That's when surfing happens, right? And that's what we do. That's called client link technology. It's the intelligence in the access point that does that. Now, what does better signal strength mean? What does it mean for transmission rates and battery life of devices? It might mean more battery life. There's actually a little study out there that Cisco's had that was done by a company that said if you have better signal strength, you can actually have better battery life on your devices. Does that have any impact on BYOD? Yeah. Think about a hospital. A hospital's got all these mobile devices running around and everything. And a nurse, would it be better if a nurse could run an entire shift with her one device without having to put it in a cradle? Or if, 6 hours and, oh my God, I've got to find a cradle for this and I have to swap it out and tell people I'm on a different device or whatever. It might make a difference. You can get sometimes, they've done tests and everything, said you can get increased the battery life up to 20-30% of your devices if you use this kind of technology. Kind of important. Again, little things make a difference, and client link is baked into our access points.
So I got a quick question. So client link was built based into the access point, I'm going to re-summarize what you said. Basically, a lines of different frequency waves to get better clarity so that you can remove the interference and improve the quality.
Right.
Then you say reduces battery life. Battery life of the access points?
Battery life of the device.
So then I'm confused because the software that is actually cleaning up the interference would be on the receiving side, not on the transmitting side.
No. Think about this. The G clients have no way, like N clients can actually talk back to the access point and say, I see these 3 waves and I'm going to use all 3 of them, even if they hit me at different times.
Right.
What client link says is if you're a client that can't tell me that, you're a client that's a G client that can't talk back to me. You weren't designed that way. What I can do is I can see me hit you 3 different times, and I can say, you know what? These waves are hitting you at different times. I'm going to adjust the transmission of these other 2 to where they're all hitting you at the same time. And your signal strength goes up. Instead of having 2 bars, you have 4 bars.
Except that you may have 1,000 different clients all trying to access you, so how do you constantly modify your transmission to...
It can do it on a client-by-client basis. It can do it.
But the clients are moving, so it's constantly updating.
Well, it may have to. Absolutely.
Interesting technology.
It's a really great technology. I'm telling you, you think of these access points, there's more to these things than meet the eye. This is very intelligent. Yes. Yes, it's actually been, yeah.
So then everybody will have it.
Well, after a while.
Gives us a value proposition.
It is now that everybody else gets it
Yeah.
as a standard.
See, think about this.
Currently, nobody has this.
Currently, now, Aruba does have something like this, but it's for a limited number of...
Only on one model, and
What?
it's explicit, it's not implicit, so there's a different way they're implementing that.
Yeah.
They haven't standardized it
Yeah.
according to...
With Cisco...
Rokus, you know?
Yes, Ruckus has something similar.
Yeah, yeah.
Their system is they have a very different system. They don't have 3 transmitters and receivers. They have like an array of antennas.
Yeah, exactly.
Yeah.
Like 10, 15, 20 on a single access point.
Yeah. But they
That's
can-
how
But they can do only a limited number of clients, I think. Is that, yeah, they can only do, we can do like, I think it's over 50 clients, 48 or 50 clients per access point. Yeah.
When does it become standard?
When is it going to become a standard? I'm not part of the IEEE, and you know what? Standards bodies lie to you all the time. They lie to you just like Emily about a report card. And that's about every time. I ask Emily all the time. Now, I'm going to talk to Emily. Today's Thursday. Tomorrow, I'll talk to Emily about her grades. We have to have a little meeting about her grades every week because she's in high school and her grades actually matter now. So I have to stay on Emily. Now, my other, I do have SPAN. But I want her to own it, not me. That's the whole point. But standards-wise, it takes 18 to 24 months for this to go through. Now let's just think about this. What you just said. It's going to become a standard. Let's go back to what we talked about in switching. When we talked about switching, do you see a pattern forming here? Cisco comes out with something that you can sell as a feature. We have it only. And because it's not a standard, now the people can wait on that standard. And while they're waiting on that standard is, guess what? So they can press it in the chips that they can buy by the billions. Right? It's going to be, as soon as it becomes a standard, they're going to put it in the next Broadcom chipset or whatever chipset they're using, and it's going to be a standard for everybody. But because Cisco builds their own, they can put these features in there outside the standard, submit it for a standard, and it may get adjusted. There are always some tweaks here or there, and then it becomes a standard. So when do you want to talk about this? You want to talk about it now. You want to talk about it on the front end. It's just like a salesperson. If you got the hottest thing in the world, you want to sell it while it's hot, not before everybody else has it. But the pattern is the same as we've done with switching and everything else. We lead the way with this stuff. Now the good part about that is we can sell it for a premium price. The bad part about that is there is a certain amount of education that has to go into a customer that makes this different and why they would pay that price. So we have to articulate our differences to the business leader to make it relevant. Because IT really doesn't give a flying flip about this. They really don't. I hate to say it, but they don't. Because they're not worried about this that much. But the business leader who might be running that, if it's a nursing person, my sister is a director of nursing at Rex Hospital. She would care about this. If you said, guess what, Sherry, your nurses are going to have to, every 6 hours they've got to plug their devices in. Well, wait a second, I got these girls running 8 hours, 12-hour shifts. Oh, well, I'm sorry. IT would say, well, sorry, we'll just put stations everywhere and they'll work around it. With this, we might say, guess what? This is for a full 8 or 12-hour shift. That's going to make a difference to Sherry. And that differentiates us. That's the thing. We're always on the leading edge of this. I've said it before and I'll say it again. Cisco does not let the lack of a standard keep us from giving a feature. And we're one of the few people who are capable of doing that because we build our own chips. We put these things in it. So client link is a differentiator.
But only on G.
Only on G, yeah. Yeah, it can actually do N too, yeah. Yeah. So there's and A, yeah. It's A and N. Yeah. Yeah. But we give better reception. Again, have you just seen, and I'd love to have your feedback on this. What did you ever think if you put a Cisco, and Aruba's a great company. I'm not going to slam them. I don't like slamming my competition. But if you ever I would love to bring a Cisco access point. I'd love to be able to pull that off the ceiling and bring a Cisco one and just hand it to a customer with an Aruba one. What's the difference? Big difference in it. I mean, it's solid. It's steel. Matter of fact, in the top of that thing, it's sealed. All the electronics are sealed inside of it. You can actually pour water in the top of it. It's got a cover in it, and you can actually pour water in the top of it and everything, and it won't ruin the electronics. You might want to show that to your customer. Just show it to them. Because it makes a difference to a customer. It really does. Theirs has holes in it. It's plastic. And it's got the same chips in it. I mean, you'll pull it out and look at it and say, ugh. You get what you pay for, folks. You get what you pay for. Our stuff is really industrial and really works. Yes, sir.
Well, so my friend from Aruba
Yeah.
and we were competing with.
Absolutely, yeah.
It's pretty common knowledge that Cisco has the only one that has their own chipset, right?
Mm-hmm.
Because Meraki, Aruba, Ruckus,
Yeah.
Ubiquiti, Bel Air, you can name
Everybody, yeah.
They all use
Mm-hmm.
the Aperus
Mhm.
chipset, right?
Mhm.
So I think that's I mean, I don't necessarily know how you, other than what we talked about
Mhm.
yesterday with, being able to do software releases that
Change the
Yeah.
characteristics of the chip.
Yeah, so I think, and maybe you feel the same way, but since we're here now, I think that's a big deal to be able to say we control the destiny of our chip, right? So everything else is Aperus. So you're confined to that
That chipset.
chipset that someone
Yeah.
else makes for you. So.
It's kind of like with switching. It's kind of like with switching. It really is. I mean, it gives us the flexibility to add these. You know, it's that moment sometimes in a lab somebody says, God, I'd love to be able to do this. Cisco's the only one who can do it. Until it becomes a standard, and then they start pressing it out in chips. And then how do you get that? You have to buy a new product. Because you're not, to replace the chip and the access point, you replaced the whole access point.
Well, that's the thing too.
Yeah.
You mentioned that yesterday.
Yeah.
Sometimes the actual access point is the smaller cost point.
Mm-hmm.
It's the actual implementation, the deployment
Absolutely.
of it, right?
Yeah.
I mean, I've heard numbers, and maybe you know more, but typically it's like, I forgot the number.
Yeah,
but
it's like it could be 3 to 4 to 1 for the difference between the installation and engineering of it versus the actual cost of the product.
It used to be 3 to 1, now they dropped it to 2 to 1.
2 to 1, yeah. 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 So there is a lot. I mean, and again, the differences are very close here, right? The price is, you know, we've got a price difference and we've got to make that up somewhere. These are little things that happen. Clean air. Cisco acquired a company that did nothing but spectrum analysis, that looked at all these different frequencies and everything. They spent a lot of money doing that, and then what they do with the chip, they put it inside of our access points. So this guy can actually scan all the other frequencies and watch for all this interference, and then when it sees interference, what's it allows it to do? Jump from one frequency to another. To move the clients off of that bad frequency that's being interfered with and move it to another. Is that important when might that be the only way you can connect to a network? Yes. Yes. That's clean air technology. Cisco has spent a lot of money to get that. They spent a lot of money to get that. And again, they spent it quite a while ago, and it's really going to really benefit them as we move forward, because we actually did it before this BYOD thing happened. So we were on the front end of that moving forward. We buy these things, and you know what? For a long time, customers have been saying, why would I want to use clean air? Why would I want to use... Now when BYOD comes about, now I think clean air might be important. So we have to make sure that we understand the position of where we're at historically along the path and what our features are. You're always going to have this. The biggest challenge for SEs and this whole Cisco thing is to keep up with technology, because we're always rolling things out. We're acquiring companies, and again, you came from an acquisition and everything. How I found out that we acquired a company like yours, I walked into a customer and said, hey, what about this latest acquisition? What? I don't know. I'll find out about it. Because we've acquired around 150 companies. And you're going to have the same thing happen to you, I promise you. What are you going to do? What happens when Cisco acquires? I didn't know about it. But guess what? I'd find out about it and start thinking about where it fits in and how it might fit with that customer, how it might not. But I'm going to have to get back to them for that. Because first of all, I'm not very smart thinking on my feet. I'm not very smart at all. So somebody has to draw it out for me. But these are the little things. Yes, sir?
What's Cisco's reputation on integrating these companies into big Cisco?
Overall, with over 140, close to 150, very good. But again, you have to understand, we've had some flops too. I mean, anybody remember Flip? Talking about flop, let's talk about Flip. Right? You know, we bought it the wrong time with Flip. We really did. We should have bought Flip years before that. Right? Because what killed Flip was the iPhone. Right? It really killed, the iPhone killed Flip. It was probably a bad, but we've had some great acquisitions along the way too. You know, I think in acquisition world, and it's hard. It's not easy to do that. It's not easy. And the bigger the company, the harder it is sometimes. But most of Cisco's technology, I mean, all of Cisco's technology other than routing and a very few part of products are acquisitions. Very, very few things we build ourselves. Very few things. And we've got a unique way of doing that we'll talk about this afternoon in data center. It's called spin-in. Spin-in. Let me give you an example, and I'll just go ahead and say this now. Cisco will seed companies, small companies. There was a small company called Andiamo. Andiamo. And that means let's go in Italian. And Cisco was trying to enter a new market. It was the data center switching, fiber channel switching market. They decided to go into that. Now Cisco could have let their own people do this, but what they did is they invested $50 million in this company. And actually a lot of the Cisco people who had built the Catalyst 6500 went and worked for that company. They left Cisco. They went from blue badge like you have to red badge like I have. I'm not a Cisco employee. I'm a contractor. And you've got what they call a blue badge. And so they actually left. They went over here into, I think it was building 13. It's one of the teen buildings over here. And they actually built the specialized ASICs and the specialized switch that eventually became the MDS 9500. And then, before anybody else had a chance for them to even release a product and everything, we spun them in and we announced we were acquiring the Andiamo company. So we fully funded it and everything. Now the reason we did that is so we could put them out there and dangle the right carrot, right? If you think about it, we told them, you make us the biggest, baddest, bad being good, fiber channel switch in the world. And as good as that thing is, and the way it sells, is how much money we're going to give you for this. So that's the initiative, right? That's the goal of the company. Make the best switch possible. Outside of the Cisco layer 8, 9, and 10, let's say. And we've done that with Nexus. Nexus was done the same way. The Nexus switching family was done the same way.
Did they do that with UCS as well?
UCS as well, yes. They've done a lot of that. They've done a lot of that. So the company's never had really a chance to do it. Now we do acquire companies who are out there in the market with unique capabilities. And again, that's been our forte ever since the first acquisition of switching. Cisco didn't build the switches or all that. They were acquiring companies and they finally said, God, we're going to have a hard time putting all these features in these ASICs. So they bought a company that built ASICs. So we built our own. So that's it. So some are good and some are bad. And you know, I think some of the good things, you know, sometimes we go back to them. I think we let WebEx hang a little too long. We didn't really fully implement WebEx like we should have early. We're doing it now because the cloud is so important. I think Scientific Atlanta was an acquisition we never really turned up. We never really made hay with it, which is something that, I mean, that's my own personal opinion. But, you know, the set-top boxes, it would have been great when we acquired Scientific Atlanta, one of the largest acquisitions we've made, to be able to put some little things in Scientific Atlanta boxes that work so much better with a core, a service provider network, and only Cisco. But we never did that. We really never did that. We kind of let them sit on their own. We actually didn't even align them to our own company very well. So that was a thing we've missed. So you'll see hits and misses. But Cisco hits more than they miss. You know, and it's kind of like baseball. If you bat 300, you're going in the Hall of Fame. That's about what it is with acquisitions, I think. I think that's it. And Cisco's probably batting 450. So they bat pretty well. But where were we? Okay, so Clean Air Client Link. How about video? Is video going to be really important? Think about Emily and how she's going to learn and all the different things. So we need more bandwidth, so they're getting that more bandwidth AC, the new standard. So we'll get more bandwidth and everything. But how about multicasting bandwidth? What if we've got a bunch of clients out here? Let me erase this. If we're streaming video, let's say it's learning videos or to streaming multicast videos to digital signs and all this, that, and the other. If we have an access point that's doing that, there's streams of video hitting this thing, multiple streams of video. And the clients out here are the ones, you know, whether they're a digital sign or an end user or somebody on an iPad, whatever it is, they're going to be streaming this. And so if I stream video, it comes in here, and guess what? Because this is a broadcast medium, guess what? This one stream of video here actually normally would hit everybody and take everybody. We'd be sending it to everybody. So what's that do? This is a digital sign stream coming in, and I'm sending it to people who don't need it. That's not cool. That's going to limit the bandwidth I have on my access point and all this, that, and the other. What if we could only send the stream to the person who needs it? So one digital stream comes in, we only send it to this person. If we unicast it to the people who joined that stream. And if this person joins another stream, we only send it to him. This person joins a stream, we only send it to the person who's joining that stream. Well, guess what? It's called a video stream. And that's technology that we've got in our access points to be able to stream 4 to 6 times more videos, multicast videos, than anybody else. That's kind of cool. That's kind of cool. And that, again, how do you make that pertinent? What if you have a retail store? A retail store. A lot of the retail stores, a lot of the movement I have, and I've got a couple of customers that I consult with who are in retail, and they all are calling it the super branch or the branch of the future or the sales of the future or whatever, all based on what Apple does. They're trying to unleash that person behind the cash register at the front of the store and give mobile devices to everybody so they can get in front of a customer, and as soon as you say yes, you can give me your card. You have no choice. You can't think about, oh God, this is expensive. And I hate if they ever do that in Talbot's. Because man, I'm in big trouble at Talbot's if they do that. But that's what they're doing. And they're talking about this. At the same time, they're talking about leveraging video for that, actually giving internet access and all this. This is really important to those people who might be doing that, because I might have 4 or 5 customers in there and I might be wanting to show them 4 or 5 different things at one time. This technology is really good for that person. Who's going to care about that? The customer will care about the experience. So anybody that cares about the customer is going to care about it, right? The business people are going to. How about the person who's in charge of that project? Somebody who's in either marketing, because marketing, this would be a big thing in marketing. Give that store of the future and all that, right? Absolutely would be important. Sales, if they're trying to drive sales per square foot up in their organization, that's certainly going to be big and important to them. We've got to get in there and talk to them about that and then say, again, we have video capabilities. We've got some really cool stuff. We've got wireless, and a lot of people have got wireless. Absolutely a lot of people got wireless, but we have video stream. And for your specific application, you might want to have more streams going, because you can give better experience to more customers and get more money out of their pockets, more dollars per square foot, or whatever your goal is to do this. That's the important part. We have to talk to those people about it. And then when the requirement comes down, it's got to be, hey, you've got to be able to have the maximum number of streams on this and everything, and that differentiates us when it goes to market. And it's going to have to be Cisco, because the requirements for the business. If not, it's going to be wireless capabilities, 802. All these standard stuff that don't differentiate us, that we have to, then we're at price, lowest to the bottom. These are things we have to make important. And if you have to, you introduce risk. Guess what? I understand you're going to do this store of the future, and now you're going to have 6 handhelds at one time on your busy days. And that's potential of 6 different video streams to 6 different customers showing your product on handhelds. That's kind of risky. Because what if it doesn't look good? What if, because we've actually got something that works with this. We've thought about this, and this differentiates us. Not only can we give you the digital signage, not only can we do all that, we actually have video stream in our... Will that differentiate us up front? Absolutely. Absolutely. That's what we've got to do. Because if you just go to IT, they may just look at this and say, video stream, what the hell is that? It can't be that important. This is expensive stuff. We got to think. We've got to get closer to the business people. Really isn't so. Does that make sense? Does that make sense? These little things. It's the little things anymore. It's the little things. It used to be, it used to be big things. My switch is faster than their switch. It's the little things that make a difference today. The little things. And these are little things. Little things.